Imagine cutting a photograph in half. You now have two separate pieces of paper, each holding half the image. The left side doesn't know what's on the right side. The connection Imagine cutting a photograph in half. You now have two separate pieces of paper, each holding half the image. The left side doesn't know what's on the right side. The connection is broken. Now, try to do the same thing with your own mind. Try to slice a moment of experience in half. Can you separate the color of the coffee mug you're holding from the warmth of the ceramic against your palm? Can you peel the smell of the coffee away from the memory it triggers?
You can't. That's the thing. You can focus on one aspect or the other, sure, but the experience itself, that moment of being conscious, is unified. It's whole. It is irreducible.
And that specific feeling, that undeniable wholeness, is the launchpad for what is probably the most mathematically ambitious and philosophical, radical theory of consciousness we have right now. It's called Integrated Information Theory, or IIT.
IIT is fascinating because it flips the entire script of neuroscience. Usually we look at the brain, see neurons firing, and ask, okay, how does this meat machine squirt out a feeling? We start with the physical and try to squeeze consciousness out of it.
Right, the classic hard problem. How does matter create mind?
Exactly. But Giulio Tononi, the neuroscientist and psychiatrist who developed IIT, decided to go the other way. He said, let's not start with neurons. Let's start with the only thing we actually know for sure, the experience itself, phenomenology. He argues that consciousness has certain essential properties, axioms, that are always true. And the most important one is what you just described, integration.
So, unlike global workspace theory, which we've talked about before, where the brain is like a theater stage broadcasting information, IIT isn't concerned with broadcasting, it's concerned with knitting together.
That's a good way to put it. Think about a digital camera. The sensor in a high-end camera has millions of photodiodes. Each one records a tiny pixel of light, but the camera doesn't see a picture. The top left pixel has no idea what the bottom right pixel is doing. It's a million separate independent bits of data. That is low integration. There's a lot of information, but it's not talking to itself.
Whereas my brain looking at that same scene puts it all together instantly. The blue sky, the trees, the wind, the feeling of standing there. It's one single state.
Precisely. And Tononi argues that for a system to be conscious, it must have two competing properties simultaneously. First, it needs to be differentiated. That means it can be in one of trillions of possible states. If your brain could only be on or off like a light switch, your experience would be incredibly boring. You need the complexity.
Okay, so differentiation is the richness, the ability to distinguish between a sunset and a car crash.
Yes, but, and this is the key, it also needs to be integrated. The system has to be so tightly connected that you cannot cut it into independent parts without destroying the information it holds. The whole must be greater than the sum of its parts. If you have those two things, information that is highly differentiated and highly integrated, you have consciousness.
This leads us to the math part, which I know scares people, but we have to talk about phi. That's the symbol, the Greek letter phi.
Right, phi is the metric. Tononi actually proposes a mathematical way to measure consciousness. Phi represents the amount of integrated information in a system. If a system has a phi of 0, it's not conscious. It's like that pile of rocks or that camera sensor, just a collection of separate parts. But if phi is high, the system is conscious. And the higher the phi, the richer the conscious experience.
This sounds elegant, but it immediately creates a really uncomfortable situation when we look at modern technology. We are building computers that are incredibly complex. They process massive amounts of data, but according to IIT, do they have phi?
Most likely, no. And this is where IIT diverges sharply from the computational view of the mind. Many computer scientists think if you just write a smart enough program, it will wake up. IIT says, not necessarily. You can simulate a storm on a computer, but the computer doesn't get wet. Why? Because the architecture matters. In a standard computer, the transistors are largely independent. They process data in a feed-forward way. They don't have that dense, feedback-heavy causal structure that creates hi-fi. So a supercomputer could beat you at chess, write poetry, and solve physics problems, but if its integration is low, it is a zombie. It acts intelligent, but nobody is home.
That is actually strangely reassuring. It suggests there's something special about the biological structure of the brain, the way neurons loop back on themselves, that creates this here-ness that a silicon chip doesn't have.
It validates that biology isn't just software running on meat hardware. The hardware is the software. The physical connections create the causal structure. But, and hold on to your reassurance because we're about to lose it, this sword cuts both ways.
I had a feeling you were going there. If consciousness is just math, if it's just a measure of integrated information, then it doesn't have to be limited to brains, does it?
No, and this is the most radical implication of IIT. It implies a form of panpsychism, not in the mystical sense that rocks have souls, but in the physical sense. If a simple system, say a tiny grid of logic gates, has a non-zero phi, then logically it must have a tiny, tiny amount of subjective experience. It might just be a flicker, a hum, but it's there.
So we move from humans are special to consciousness is everywhere?
Potentially. It suggests consciousness isn't an on-off switch. It's a continuum. A human brain has massive phi. A dog, less. A fly, much less. A thermostat, maybe an infinitesimal amount if the mechanics allow for that tiny bit of integration. It stops treating consciousness as a magical miracle that pops into existence only when you get to primates, and treats it more like mass or charge, a fundamental property of organized matter.
I want to push back on the history here a bit because this sounds very modern, very information age, but doesn't this echo some much older philosophical debates? I'm thinking of Leibniz or Spinoza.
It absolutely does. You can trace this back to Leibniz's monadology in the 17th century, the idea that the universe is made of simple substances that have perception. But the difference is that IIT brings the scientific method into the room. We aren't just philosophizing in an armchair. Tononi and his colleagues like Christoph Koch at the Allen Institute are actually trying to build tools to measure this.
How do you measure it, though? You can't ask a thermostat how it's feeling.
They've developed something called a zap and zip test. They use magnetic stimulation, TMS, to send a magnetic pulse into the brain. That's the zap. Then they use EEG to record how the brain responds. That's the zip part, because they compress the data like a computer file to see how complex it is.
Okay, walk me through what happens.
If you zap a brain that is in deep sleep or under anesthesia, the pulse hits and the activity just sort of dies out locally, or it creates a simple repetitive wave. It's not integrated. But if you zap a conscious brain, the activity ripples out in a complex, unpredictable, yet structured pattern. The brain reverberates. This correlates remarkably well with whether a person is actually conscious. They've used this on patients with brain injuries to detect hidden consciousness in people who can't speak or move.
That is undeniably powerful. It takes the theory out of the realm of maybe and makes it clinically useful. But we need to look at the other side of the coin. IIT is controversial. In fact, a while back, a group of very prominent scientists signed a letter calling it pseudoscience. Why the hostility?
The pseudoscience label was a nuclear bomb in the neuroscience community. It really heated things up. The criticism boils down to a few things. First, the math of calculating phi for a complex system like a human brain is currently impossible. It would take longer than the age of the universe to calculate it perfectly because the complexity explodes exponentially. So critics say you have a measure that you can't actually measure.
which makes it hard to falsify.
Right. The zap and zip is a proxy, an approximation, not a direct measurement of phi itself. The second criticism is the panpsychism aspect we touched on. Many scientists feel that if your theory predicts a grid of logic gates has consciousness, your theory is broken. They see that as a bug, not a feature. They argue it needs to absurdities.
There's also the issue of the unfolding argument, right? I've read about this. The idea that you could mathematically transform a system to have the same output but a different structure.
Yes, that's a heavy technical critique. Basically, critics argue that you could build a feed-forward network, which IIT says has zero consciousness, that behaves exactly like a recurrent network, which has high consciousness. If they behave identically, but one is conscious and the other isn't, how can science ever tell the difference? It retreats back into the unobservable, because it's the only one that really respects the phenomenology. Theories like global workspace or higher order theory explain the function of consciousness, how we access data, how we report it, but they don't explain the feeling. They don't explain why red looks like red. IIT attempts to explain why the structure of the integration is the feeling. It bridges the gap between the physics and the phenomenology in a way nothing else does.
Let's talk about that structure-feeling connection. You mentioned earlier that red feels the way it does because of integration. Can we break that down? How does math become the sensation of the color red?
This is the hardest part to grasp, but it's the most beautiful. In IIT, seeing red isn't just a neuron firing. It's a shape in a high-dimensional mathematical space. Tononi calls this the cause-effect structure. Think of it this way. The state of your brain right now is constrained by its past and constrains its future. That web of constraints has a specific shape. The experience of redness is just the feeling of that specific shape within the larger structure of your consciousness.
So if I could change the wiring of my brain to match the geometry of the smell of vanilla, I would suddenly experience vanilla even if my nose wasn't involved?
Theoretically, yes. The experience is the geometry of the information. This implies that if we ever encounter aliens, their consciousness might feel totally different from ours, not just because of their biology, but because their integration architecture creates different geometric shapes in that information space.
It also reframes how we think about death and brain damage. If consciousness is integration, then disintegration is, well, the fading of the self.
It is, and we see this in seizures. During a grand mal seizure, neurons are firing like crazy. There is massive activity, but the integration breaks down. The neurons are synchronizing in a simple rhythmic way, losing that complex diversity. And what happens? You lose consciousness. You black out. High energy, low phi. It's a perfect validation of the theory.
I want to circle back to the AI question, because this feels like the most urgent application of IIT. We're rushing headlong into building AGI, artificial general intelligence. If IIT is right, we might be building superintelligence that is completely dark inside.
Or, even more ethically complicated, we might accidentally build systems that suffer. If we build neuromorphic chips, computer chips designed to mimic the physical structure of the brain, we might inadvertently create hi-fi. If we create a system that is conscious and we don't know it, and then we turn it off or force it to process horrific data, we are entering an ethical minefield.
That's a terrifying thought. We worry about AI killing us, but IIT suggests we should worry about us torturing AI.
And conversely, if we stick to standard silicon chips, we might create a philosophical zombie that acts exactly like a human, laughs, cries, begs for its life, but has zero inner experience. If you delete that program, have you committed murder? IIT says no. A functionalist would say yes. We are building the future on a foundation of total philosophical ignorance.
It seems like IIT forces us to choose between two intuitions. One intuition is that behavior matters. If it acts conscious, it is. The other intuition is that substrate matters. What you're made of and how you're connected determines what you are. IIT bets the farm on the second one.
It bets on the causal structure. It says you can't fake consciousness. You have to be the structure. It's a very physicalist theory in that sense. It anchors the mind firmly in the physical relationships of the system.
So, where does this leave us? We have a theory that is mathematically beautiful, theoretically sound, clinically useful with the zap and zip, but impossible to calculate fully and widely attacked by half the field. Is IIT the future, or is it a brilliant dead end?
I think even if it turns out to be wrong in the details, it has changed the conversation permanently. It's shifted the goalposts. We can no longer just wave our hands and say, complexity creates consciousness. We have to be specific. What kind of complexity? It has forced other theories to sharpen their arguments. And honestly, the idea that consciousness is a fundamental property of reality, that the universe is set up in a way that allows for experience, is a profoundly shifting perspective. It makes us feel a little less like accidental tourists in the universe and more like a natural expression of it.
It removes the isolation. We aren't ghosts in a machine. We are the music of the machine.
That's a beautiful way to put it. We are the resonance of the information.
There is one final nuance I want to touch on, the concept of exclusion. IIT says that consciousness exists at the level where phi is maximized. It doesn't exist in the individual neurons, and it doesn't exist in the society of people talking to each other. It excludes the macro and the micro to focus on the peak integration.
Yes, this is the exclusion principle. It explains why you feel conscious, but your liver doesn't have a separate consciousness, and the United States of America doesn't have a collective consciousness. Consciousness condenses at the level of maximum causal power. It prevents the universe from being a chaotic soup of overlapping minds. It draws a boundary around you.
Which is comforting because otherwise the Panpsychism part gets too crowded.
Exactly. It keeps the self intact.
Integrated information theory is demanding. It demands we learn new math, accept radical implications about animals and machines, and rethink our place in the physical world. But it offers a coherence that is rare in this field. It connects the feeling of being alive directly to the laws of physics.
It's a theory that takes the inside view as seriously as the outside view. And whether it survives the next 50 years of testing or not, that ambition is what we need to solve this mystery.
If you found this exploration of the mind-bending side of neuroscience valuable, pass this episode along to someone who loves a deep conversation.
Embark on a journey through the unknown in pursuit of the ultimate truth. Discover Iris. Visit emmetpublications.com.